So many tapes. Where do they go? What are they all for? Let's get into it. Welcome back. So in the last episode, we talked about air sealing and air management and vapor control and that kind of stuff. So we're going to take a look at a project we recently did, show you guys some of the products we used, how we used them, why we used them, and just show you some of the assemblies.
So this project is a pretty basic addition off the back of a house. We just extended the dining room, and the future plan is for them to make their kitchen bigger and have a little extra living space at the back of their house.
So you want to start on the outside?
Let's start on the outside.
Okay, we'll start on the outside. So on the bottom at the outside, we took the zip sheathing all the way down. So zip is basically an OSB with a water and air barrier, liquid applied coating. And so the idea is that you don't need your typical house wrap. It's already airtight, watertight, right from the factory as a sheet. But there's some caveats to that. You also have to use tapes for the seams, and then you can get into liquid flash. And so that basically will cover gaps and cracks and splits and any scratches you have in the coating, and also over top of all your nails and stuff that are not hidden by the sheet good or the tape. Yeah. At the bottom, we used Proclima Contigo Solido IQ. I don't know who comes up with these names, but it wasn't a newfie. I can tell you that much for sure. Anyhow, so this tape has kind of a fabric-y back to it. The idea is that, first off, it sticks to everything, porous or not, so it sticks to concrete really well, it sticks to plywood really well, and it has a texture on it. It's kind of felty kind of a feel. The idea is that concrete for doing your parging on the foundation stuff will stick right to it, so you don't have to worry about if you had like some kind of a plasticky type tape that it would not stick or bond. So this stuff will bond right to concrete and whatnot as well. So anyway, so that goes to the bottom. Same sort of application. You have to put it on, wipe it down because it's all pressure adhesive. So you have to do that to make sure you get a good strong bond, and then you work your way up, and then you get into some of the window details.
Yeah. So going back to the zip system, we like it from a construction perspective because as soon as the wall's standing, it's weather tight, and you're not going to have issues with water being held inside just from during the construction process.
Yep.
So it acts as our primary air barrier, it acts as our WRB, and yeah, like I said, as soon as the wall's standing, it's ready to go. Around the windows, we're able to tie the zip system sheathing inside the window, like inside of the buck, and we tape that with the stretch tape and with the normal tape, depending on where it is. And again, we can totally seal the whole thing before the window even goes in, and then once the window's in, we take care of our regular flashing details and everything like that.
But it's bomb proof before the window goes in.
Absolutely.
Basically, it's 100% watertight, really, before the window even goes in. So even if the window was leaking, if you do the proper layering, angled subsill, and then with the stretch tape, like it's 100% done.
Yeah. So something we have to acknowledge is that all of these products are significantly more expensive than using standard tuck tape and Tyvek and things like that. There's a reason for it. They do a really good job. They're super durable. We worked out that using the stretch tape, for example, on the bottom of a window, this stuff is super expensive. It ends up being about $20-ish to do the bottom sill of a window in the stretch tape.
It's about $3 a linear foot. So yeah, so it's not inexpensive by any stretch of the imagination. But again, like you said, for a 4-foot window, if you call it $20, spend $20 to make your window 100% waterproof at the sill, so the wood never gets wet, never gets damaged, the wall below never gets ruined. I don't know, $20. I spent $20 on worse stuff. I know that.
So now we're moving inside. Inside, we're really focusing on vapor control and a secondary air barrier, just to keep it nice and airtight and try to do it properly.
Yep.
So let's start in the basement. This was an addition with the basement, so they have access from both floors, extra living space in their house.
Yep.
What do we do for the floor in the basement, Ernest?
So in the basement, rather than doing concrete, we decided to go with SI Construction's R floor, and that's just a warmer floor for below grade
Yeah.
level. So
Yeah, so it's a 5.5-inch EPS panel with embedded steel studs for structure.
Yep.
Usually, they start with 4x8 sheets and cut them down as needed,
Yep.
and you just lay down a bed of sand, compact it, and then set your panels in place.
And yeah, that's kind of it. And then
Yep.
your subfloor holds it all together as a system. And then before your subfloor goes on, you put a vapor barrier down. Rather than a 6 mil poly, we went with Stego. It's a 15 mil, so it's class 1, obviously, and it's just way stronger. Since you're walking on it, we wanted to go with something that's a bit more durable. And so we went with the Stego product. So that's how we did that.
So the Stego wraps around, it sits on top of the R floor, and then we lay our subfloor down, and then it can wrap up and around and tie into the vapor barrier on our frost wall.
So in the basement, before we actually built the frost wall, we actually did an 1.5 inch layer of comfort board around the perimeter of the foundation, just to do a continuous layer of insulation all the way through to make the space a bit quieter, a bit more comfortable. So we did that, and then we took our vapor barrier up. And before we built the floor, even we can kind of go back there. Before we put the floor on, we actually took IntelliPlus and put it on top of the foundation before the joist went on. The idea was to create a continuous air barrier. If you take the red line test, from the bottom, we can trace that all the way through the floor assembly. The floor assembly is always the hard part to really get the air tightness, because you have to start and stop so many times. So with the forethought of putting it down before we put the joists on, we're able to make that layer continuous all the way through the building. So yeah, then we attached at the top and at the bottom, and now it's continuous all the way through that assembly.
Yeah. And then we have our dense pack cellulose filling that cavity for 18 inches or so.
Something like that. It's quite a bit.
So there's still a lot of warmth in there.
Yeah.
That definitely helps. So when this ties up, once we got our wall, we folded this over the subfloor, got our walls standing, got everything built, and then we were able to, after insulation, we ran more IntelliPlus up the wall and tied that into the flap we had hanging out here. And then at all the windows, we were able to tie into the zip sheathing that wrapped onto the inside. So we have a continuous layer there. And then same thing at the top of the wall. We wrapped over top, tying into the zip again, and then another flap tying into the ceiling here. All of these are sealed together with, I forget what it's called.
Contiga HG.
Contiga HG.
I don't know where the names come from.
That's a Proclima one, right?
Yes.
Yeah. So those are all sealed together, and then we come up here and we'll show the skylight detail we dealt with. So the skylights were a fun detail to figure out.
It was.
Skylights are terrible if you're trying to build a high performance house. They don't.
It really is.
There's, as far as air sealing and thermal bridging, they're just not good. But if a client wants a skylight, we have to try to find the best way to install it where it's going to
perform better
and not cause problems.
Yeah. So what we did on this particular job was, as opposed to just going with 6 mil poly up across that solid 2x6 curb on the roof deck, we actually took a layer of 1/2 inch EPS, XPS, I think it was? XPS foam around the perimeter on the inside. And before we did that, we took a layer of this Contigo Solido IQ-D. Again,
there will be a test.
There will be a test. So this stuff, basically, it's similar of the foundation stuff. It sticks to everything, except this also has a sticky strip on the back side as well as the front side, the other side. So anyway, so we took this and we were able to tape it around the perimeter before the insulation went on, and then brought it up so that way when we brought our IntelliPlus up and tied into it, we could tape it back down on top. So again, just keeping that continuous air seal and vapor seal up and over around the inside perimeter of the curb for the skylight, which normally is just solid dimensional lumber. So even though the 1/2 inch material is only an R3, if you think of dimensional lumber being like R1, it's 3 times as good.
The roof in the addition, the entire thing is vaulted. At the heel, we have around 16 inches. At the top, we have 40 plus. At the skylights, it was in that 3-foot range.
It varied because it was tapered.
So we filled the entire thing with dense pack cellulose just to, instead of trying to get in there and frame little walls here and there and try to save a little bit, we just filled the entire thing. More insulation can't hurt in this situation. And then we have it vented along the top with baffles as needed to make sure we actually get proper airflow. There's a ridge vent and a vent down here. So tying into the existing house took a little bit of planning. But what we did, so where that beam is, you can see in the picture, that's where the existing exterior wall of the house was. Yep. So when that came out, we had to add some posts and put that beam in. We put a layer of Intello Plus above the beam, and then we were able to tie the existing poly in the kitchen into it and tie our new Intello Plus on the addition side into it, instead of wrapping the entire beam into the attic space.
I feel like doing it that way kind of creates a pocket for any condensation that could accumulate. So I think that was well worth going that route. So
felt like a cleaner detail.
It did for sure. Now the beam is on the inside and the roof is on the outside. So I like that. I like that better.
And then we also did a service cavity on the roof or on the ceiling. So when the electrician came in, they had poked their wires through before we insulated the roof, but they had a minimal amount of them, and then they were able to run all of their connections in the service cavity to avoid having more penetrations for no reason. So back to our air and vapor sealing assembly.
Red pen test.
Red pen test. So we can go all the way from the basement, up the frost wall, around the outside here, back into the house, and all the way up, and that ties into the existing. Did not lift the pen the whole time. So
I guess a pass.
That's a pass. Mission accomplished. We're pretty happy about that. We don't like having funky details where you're spending so much time trying to seal up a million different holes. Yeah. This feels like a good way to have a nice consistent line where everything's sealed the whole way across. We acknowledge that in this case, the addition is 18% of the square footage of the house, somewhere in that range. Yeah. Big picture in the performance of the house overall, it's not making a big difference, but we can feel confident that everything we touched is going to be durable, going to last a long time. This is a south-facing room in a really windy part of the city. They're going to have a lot of sunlight, a lot of wind. It should be comfortable in that space, even though it's open to the rest of the house.
Yep. So when you're talking these high-performance products and stuff, let's not kid yourself. These are not inexpensive products. At the same time, though, if you think of a high-performance house, these materials, these products are only used for a certain number of places. Like your kitchen's still the same, your roofing, your shingles are still the same, your foundation's sort of the same, like putting on doors, it's all sort of the same inside. So it's just a select few materials that are high performance and cost more. With that being said, like this is Intello. So this is a piece that we had left over on that last project. So it's not super large, but it's worth saving. Whereas if this was 6 mil poly, like no one's going to hold on to this.
It's in the garbage.
It's in the like pieces even bigger than this are going to be in the garbage. Where I feel like even though these products are more expensive, you use them more consciously, like the tapes and stuff, like that go along with this. It's like Tuscan Banner and stuff. Like these tapes and stuff are like 50 cents a foot, for instance. Like you're going to be conscious when you're pulling off a piece to use it. You're going to actually be using the spreader to wipe it down and stuff because I feel like you're more conscious of everything, the cost of everything. So you're going to try to use it to the best of your ability to make sure they're actually performing the way they're supposed to perform. So I think there's something to be said about that as well. That you definitely you pay more, but you waste less, I think. So
yeah, it's all the same. And for example, you wouldn't want to buy zip sheathing and use tuck tape to seal in between. You buy their tape, you use their tape. We've heard of that. We've heard of people doing that. So, but yeah, you want to when you're spending that much money and taking the time to do it, you want to make sure you're actually getting the results out of it that you're paying for.
Totally. Yep. Yeah. And that's, I think, where different products not being accepted sort of to a certain degree. But I think it's that case, right, where people are taking like zip sheathing and using tuck tape on it, thinking a tape's a tape's a tape. Well, I can tell you, that's not the case. Yeah. And you really have to use the specific products for the specific products.
So that's all we have for today. Hopefully it was informative or entertaining, laughing with us or at us, either way.
Either way. Thanks for watching either way.
Yeah, we appreciate you tuning in. We're trying to get as much information out there as we can based on what we're learning every day and to open up the conversations so that we can all do things better and build better.
Continually building better.
Thanks for watching.
Thanks.